This is a video to help you through Experiment 1, a Matlab orientation activity. This video complements your laboratory manual starting on page 43, Experiment 1, Assignment 1. In Matlab, I've already got experiment1.mat and Lsq, my script, installed in my Matlab folder. If you're not sure how to do that, look at the previous video where I explained how to install a custom script. You will need this for the activity. If you're using Matlab through FastX, these things are already installed for you through the Bohr server. The first step is to load the data that I have in this experiment1.mat file. So I type the command load and then the file name. Now I see that over in my workspace, I've got two variables that have been defined. They are each an 80 by 1 matrix. I can actually see what those variables are. If I type each one of them, I can see X, for example, is a very long vector that runs from about 600 to 1,000, and Y is also a vector that runs from values of 6 to about 0.2. The instructions in your lab manual explain a little bit about these two variables, but your first instructions are to plot this data. So to plot X, Y, I simply use the command plot, and then I put the name of my X variable and the name of my Y variable. If I stop there and close the parentheses, it will give me a plot that looks something like this. If you'd like to change the way that the plot is displayed, you can. So, for example, if I want to plot X, Y, but I don't want to see a line connecting the data, and instead I want to see only symbols, I can choose my symbol like an open circle with a lowercase o and press enter, and now it changes the depiction of my data on this chart. There's other ways that you can change depiction here, and that is by going into View and Property Inspector. In the Property Inspector, you'll need to hover over Figure 1 and drop this drop-down menu down. Click onto your symbol and line, and then you can choose things like the color. So under color and styling, I could choose purple symbols instead of blue, for example. I can change my line style if I wish to a dashed line between the data. So I can change the style, or I can turn that off by choosing none. You can also change the line thickness, and you can change your markers. So if I wanted some other shape instead of a circle, I can do that here. You can do these same things using commands, but you don't need to learn those commands if you just access this menu. Again, it's under View, Property Inspector, and you need to drop this menu down under Figure 1. There are commands that you can use to type or to add X and Y axes labels here and a title. You can also do that through this insert feature. So this is my X and Y axis, and these are my X and Y variables. And I'm going to go ahead and give this a title. To save a figure, I'm going to use this save icon the first time. There are many different formats in which you can save figures here. If you save it as a .fig file, then you can come back later, open up this file, which is now saved in the folder that you're working, You can open up this file in Matlab and edit it. So you could change the symbol shape again, or you could relabel the X or Y axis or something like this. I recommend always saving your Matlab figures in a .fig file and also saving them as a JPEG or image file so that you can insert them easily into your electronic lab notebook when necessary. So if you followed along so far, you've completed the very first part of this activity. In this assignment, the next instruction is to use Matlab to recalculate the data in linear form using the natural log of y versus x. There are many ways you could do this. I'm going to go for the one that requires the least amount of typing. Oops. I'm going to plot x and the natural log of y. Notice that I used log for natural log. Matlab uses this command for natural log, and I just want to point this out because it's a little counterintuitive. You probably are used to seeing log mean the log base 10, but in this case it's log base e, or the natural log. So I'm going to plot the log, and this time I'm going to ask it to give me symbols of x. And now you can see that the data is in a more linear relationship when we have the natural log of y versus x. So I'm going to go ahead and label the axes again. Now when you go to save this, if you hit the save button, it will overwrite the file that I saved earlier. So be careful with using that icon. I'm going to go ahead and save it as now, and instead of the same file name I used earlier, I'm going to change the file name so I don't overwrite my previous file. That saved it as a JPEG. I'm going to now again save that as a FIG file. The next step is to find the best fit line here. So there's a couple ways I can do that. To get the line onto my plot, I could use Tools, Basic Fitting, and I can choose Linear Fit. I can choose to put the equation on the plot. I can show my R² value if I wish. There's some other options down here as well. But once you've chosen your options, it automatically plots that data, and so here I go. So here's the best fit line. Once again, if you wanted to change anything about that, you can go to the property inspector. Now I accessed it by double clicking on the legend. And I'm going to change my linear relationship to a dark red line. The next step you need to do is determine the A and C values from the equation that you were given in your laboratory manual. I'm going to type that equation on the chart using a text box. We can convert this equation into a linear relationship in the form of y is equal to mx plus b if we take the natural log of both sides of this equation. If we take the natural log, then a plot of the natural log of y versus x would match what we see in front of us. So here I've taken the natural log of both sides of the equation, then I've used a logarithm rule to separate my A value from my C value. The natural log of an exponent e is just the value of that exponent here. And if I just rearrange this equation, now I have it in the form of a y value, which happens to be ln of y, is equal to mx plus b, or basically this value, the slope will be the negative of our C value, and our intercept will be the natural log of A. So from this information and from the slope and intercept, you can determine what the values of C and A are. The instructions in your experiment explicitly tell you that you should give the standard deviation of these values. To calculate the standard deviation of a slope and a y-intercept, we can use the custom Lsq script that's provided for you. I'll use this script by typing the command lsq of my x and y variables. In this case, I wanted to perform the Lsq script on x and the natural log of y. And here I get the same slope and y-intercept that I got with my best fit, but now it gives me the standard deviation of that slope and the standard deviation of the y-intercept, which I can use to report the uncertainty in my values. Notice that I'm using LaTeX here for symbols. Any LaTeX that you add into a text area in the Matlab figures will show up as the appropriate symbol. So this is now a completion of the second part of this experiment and the second plot that you're asked to do for assignment 1. So I've just determined the value of C, and I can determine the value of A by taking the exponent of the y-intercept. And now I can use the value of A and C in this equation to plot a line that will give me the best fit of my raw y versus x data. So I'm going to define that function here. Y is equal to A times negative C times x. Except I don't want to define this as y, because if I do, then it will overwrite the variable y that I have already defined. So I'm going to change that and just define it as a function. So this is the function that was given to me as in the lab manual, where it told me that the data in this experiment1.mat followed this relationship. So if that's true, then my function f should give me a best fit of that raw data. So I'm going to try now. I'm going to plot x, y with open circles. And I'm also going to plot x, f on the same plot with those two, but the second plot will be a straight line. Now, before I hit that command, I actually want to save this. So I'm going to save this, and I want to overwrite my experiment 1-1-2. So I'm just going to go ahead and hit the save button this time. And now I'm going to save it as the JPEG as well. Okay, now when I hit the command to plot, replot, oh, I have a problem here. And it's because, that's why. I defined my, this needs to be a negative. Oops. There we go. And I can delete this and relabel my X and Y axes. Now I'll save it as a new file name, and as a .fig file. And that is the end of assignment 1.